So this is a symposium was developed by the RIST activity group and the RIST forum. The primary people who did all the graphics work and put most of this together was myself, as well as Cyril Narana from Cobalt and Addie Rosenberg from VideoFlow. So give credit where credit is due. Why is it? Hang on. You're having an issue every time I hit this. Okay, there we go. It was weird. Every time I hit the space bar, it muted me. So what are the challenges facing technical decision? Pardon me. Okay. So the agenda is, what are the challenges facing technical decision makers? What can RIST do for me and for you? What is the RIST forum? And I will get into that. A quick overview of RIST features and benefits, and application scenarios and case studies. I will warn you in advance, even though the presentation that comes out later this month has the actual names of the broadcasters and the case studies. This presentation, I just put generics in there because they gave permission for their names to be used for the RIST panel. They didn't necessarily for the SMPTE meeting, and I wasn't sure. So I just simply pulled out the names of the actual end users. But after the presentation is done, May 4th, we can put those back in. So, what are the challenges facing technical decision makers? Well, international contribution and distribution. There are many changes in the broadcast industry pushed by management and also often accountants, to put it nicely. We all know the reality of wanting to do things and not being able to due to costs. Expenses of private leased lines from regional telcos, and probably a good thing we're not meeting at Turner today, because I'm talking about taking money out of AT&T's pocket. So, wouldn't be nice to actually be meeting there and talking about how not to get them money. But anyway, endpoints might not be easy to relocate. One of the obvious uses is where, and somebody else needs to mute, last mile, where very often you may have a private carrier for long haul or international. But getting that last mile circuit in may cost you, more money. To get from the local CO to where you need to be may cost you more than to get from Atlanta to London. Point to point by definition, and lines may lie idle for long periods of time. Do you want to spend several $1,000s a month on a circuit, which you only use occasionally, or maybe only use for a news feed when the NFL team happens to be playing one of their 8 games a year in the stadium? And what about satellite delivery? C-band frequencies are being repurposed, as I mentioned, at the SMPTE meeting a couple months ago, for 5G wireless devices. Primary distribution means first getting the feed to the uplink. So even if you have, say, a big C-band uplink, how do you get the feed there? Need for cost-effective alternatives, and some of these can be like microwaves and stuff, can be even more lossy than the internet. So the other challenge we are all facing is working remotely, something which has really come to the forefront over the last 6 weeks. And obviously there's a lot of use being made of the internet, and yes, there is a lot of RIST product that has been forced out over the last 6 weeks and is being used on a wide variety of TV shows. Far more than a couple months ago we ever dreamed would be needed. But this stuff is being used very widely right now, with demand through the roof, both for RIST and for other similar products. Besides just, while I'm talking about RIST, there are other non-RIST, obviously, appliances that are being used like crazy right now due to the COVID-19 remote workflow requirements. Many workflows are migrating to the public cloud infrastructure, including AWS. I will point out that AWS is a RIST partner, and as are some other providers. Try to weigh the cost of cloud storage and bandwidth on a premium cost, and can our existing services and equipment migrate to or integrate with cloud services? And that's important right now. As you need to work in the cloud, as obviously like everything else is being done at a level unimagined just a few weeks ago, RIST is fully cloud compatible, which I can actually will show you later. So what can RIST do for me or for you? So if you want to use the internet as a cost-effective means of transporting high-quality broadcast-grade video, unfortunately, there are issues. Delivery through the internet is not guaranteed, and it may take glitches. You know, there is no QoS on the internet. You're at the mercy of everybody else using the internet, both globally as well as locally. If you're like on a cable modem, you and your neighbors are all sharing the same bandwidth, and that can be an issue. Many solutions add a lot of latency, which is not useful for live cases. That is something that is, you know, we've all dealt with that. You know, we see the anchor ask the question and the person out in the field nod their head 3 times before they finally answer. Needs content to be protected so it doesn't get stolen, which means it needs to be secure. Now, I've given presentations before to the local section about RIST Phase 1, which has been out for about 1.5 years. That did not have any security on it. RIST Phase 2, which was published a month ago, has full security. And people need to not be able to hijack your feed. You know, we've all heard some of the stuff with some of the instances of people using Zoom and other cases like that for classroom experiences when things popped up that weren't supposed to be there. You know, people getting Zoom bombed. Zoom isn't the only one that can deal with that, but we've all heard that term. So it needs to be secure that nobody can hijack your feed. Pull a Captain Midnight, for those of you who can remember, about 35 years ago. And many IP people are very busy, and they need a straightforward approach to set up. Now, other people have solutions like this. A number of solutions that meet these requirements have been available for a while from various vendors. So why is RIST different? Obviously, it was as discussed. RIST is interactive. It's a joint venture between many of the leading companies that provide video delivery over the internet. I wish I could say all the companies, but many of the leading companies. It is a best-in-class service approach, and it is interoperable. So you're not locked into any particular company, and that's the big thing about RIST. I can buy an encoder from company A, I can buy a decoder from company B, it can interoperate. So who is behind RIST? So there are 2 parts to RIST. There's the technology side, which consists of the Video Services Forum. The Video Services Forum does the technology of RIST, but the VSF decided that they did not want to be in the marketing side of things. So a separate entity was created called the RIST Forum. Oh, by the way, just as a side note, Bob, Narshet, you might want to take your camera off right now. Say, you know, we say everybody to mute. Everyone will mute audio and video. If you have a question, by the way, feel free to chime in at any time, and you can chime in on audio and video if you want. We just ask you to keep your audio and your video muted unless you're asking a question. All right. So anyway, we have the RIST Activity Group. That's part of the Video Services Forum. It does all the technology work for RIST, and that is headed up by me. In fact, I'm the, you know, I've sort of said maybe I'm the redhead right here. I don't know, kind of works. And why did the arrow go away? Anyway, so then there's also the RIST Forum. The RIST Forum is a separate marketing entity that markets RIST. The RIST Forum does not deal with the technology. It is strictly a marketing entity. And the reason for that was the Video Services Forum decided its charter does not allow it to be in the marketing business and to try to push a product. So the RIST Forum was set up as a separate legal entity. So the RIST Activity Group under the Video Services Forum deals with all the technology. The RIST Forum deals with the marketing and markets RIST, but does not deal with technology. If anybody has says that anything technically needs to be done different with RIST, that has to go back to the RIST Activity Group. So the RIST Forum strives to promote a common interoperable specification, reliable internet stream transport for transporting live video over unmanaged networks using best-in-class technologies. Sorry for the plug here, but this presentation was originally developed by the RIST Forum. So even though I pulled all the marketing stuff out, I figured I'd give them one slide. Leading members who are involved with it, these are the companies that are part of RIST and the RIST forum. So you can see there are lots of companies involved. The only reason for who's up on top versus down lower is how much money they give the RIST forum. It has nothing to do with their technical involvement. It just has to do with what level of sponsor they are of the RIST forum. But as you can see, major providers, including Amazon, NetInsight, Cobalt, Evertz, Artel, Nevion are all heavily involved with RIST. And so is Haivision. Obviously, Haivision is behind the competing format called SRT, but Haivision is involved in both camps. And since the RIST forum is an open activity group, anyone who wants to be involved can be involved. As we've said all along, if you're using RIST, you are not required to only use RIST. You do not have, if you have some secret sauce that you think that you can deliver something somebody else can't, you are perfectly allowed to keep your proprietary technology, but your equipment, both transmitters and receivers, have to fully support RIST. That doesn't mean you can't have a non-RIST mode on your product. But if you're in RIST mode, you have to be fully compliant. So the overview of the technology. So the RIST roadmap, and this deals primarily with the new main profile. It's about smart bandwidth optimization, common channel session management, centralized call home. In other words, it allows single control of the remote devices from a home unit, as well as third-party location control. Now, within the main profile, let's see, is my mouse moving? You can see my mouse there. The main profile is what's now been added recently. So, and the simple profile is what's been around for a couple of years. Simple profile was pretty simple. It was interoperable with support of ARQ, retransmission throttling, link aggregation and bonding if you had multiple paths, and redundant transmission paths, which goes in with the aggregation and bonding. That's been around for what we've added in the main profile. This is what's new. Multi-stream tunneling. In other words, once again, within the tunnel, you can carry multiple streams, as well as multiple tunnels for a stream. Stream encryption. So it is secure, full authentication, high bitrate support. In other words, there is no high-end cap on how big your pipe can be with RIST. If the hardware can support it and your internet pipe can support it, there is no high-end limit. So in theory, if you wanted to send 12 gig 4K uncompressed over the internet, if you had a big enough internet pipe and you had fast enough RIST hardware, you could support it. There is nothing prohibiting you from doing it. And then null packet suppression is just something we've added to get rid of the null packet and save you in your data rate. So here's the RIST timeline. The whole process really sort of kicked off in February of 17. We had the first draft of the simple profile in April of 18. We did our first interop in May of 2018. The second draft of simple profile in July of 2018. In September of 2018 was when we did our first public interop of the simple profile. And then in October of 2018 is when we published the simple profile. It was also at that point that the RIST forum was created as the marketing entity. Everything prior to this was strictly within the video services forum. In April of 2019, we had the first commercial product availability. That's actually not totally accurate because actually some folks were updating the various drafts of the simple profile into their product as we went along. So you could actually technically say that there were folks operating in simple profile before simple profile was even published. Main profile draft and interop was in September of 2019, and in March of 2020, the main profile was published. Coming up next, we are currently starting work on the advanced profile. So work continues. We are also working on some revisions due to some enhancements that have been made to the simple profile. Those should come out in a couple of months. The enhancements, however, are written so they are totally backwards compatible, meaning if, say, you have a sender or a receiver that has the an enhanced version, it will properly handshake and work with something that does not. So everything defaults back to earlier versions. So the simple profile, the base stream is a standard RTP. It's compatible with non-RIST devices without protection. Obviously features packet recovering using ARQ. I've gone over in the past what ARQ is, but the bottom line, in a simple form, it's if the packet didn't make it, say I didn't get the packet, send it again. In its simplest form, with some smarts to make certain you don't waste your time resending packets over and over that don't make it. It has multi-link support, so you can spread your data over multiple links, and there's some graphics later on as for how that goes. Seamless switching if you have multiple links. So if you lose a path, you can go to the other path, assuming it has enough data. And like I said, and companies are free to innovate and improve the products without losing compatibility. So if you have single-ended things you can do, that's fine, but it has to be compatible with the main with the profile. The main profile supports tunneling, so multiple streams can combine into a single UDP port. What RIST main profile is it's a multicast stream encapsulated within a unicast tunnel. There is we are defining it as a tunnel. Some people may say, when you say a tunnel, do you mean a VPN? The answer, you can think of it as a VPN, but there are some legal reasons why we don't call it a VPN. Since there's nobody currently on the call in mainland China, I can say part of the reason we call it a tunnel is that tunnels are legal in China and VPNs are not. So therefore, it is a tunnel. So they can be initiated by either endpoint. See, in the simple profile, you had to originate everything from the sender, from the transmitter, and you had to have the IP address of the receiver. Within the main profile, you can connect from either point, or through a third-party location. So you can have a receiver that can connect to an offline sender or a standby sender. The sender can connect to a receiver. So the connection can go either way. If you have to go, it also helps if you have to go through a firewall. There may be a reason you can go through the firewall in one direction, but not the other. So you can originate the connection anyway, and either way you need to. It's also compatible with third parties. So if you're going to a cloud provider, which may be necessary so that both of your tunnels, both from the sender and the receiver, are officially outgoing, we're connecting up with a cloud provider, once again, to deal with firewall issues. Has optional support for any type of out-of-band IP data. So if you need to piggyback data, whether it be PTZ for a camera or shot clock data, which is something that I've had to deal with, it has ancillary data that can ride along with everything else within the RIST tunnel. It has encryption. The main profile offers configurable encryption. It's AES 256 in those places where you're allowed to use it. AES 128 for places where you're not allowed to use it, such as China, Russia, Saudi Arabia, where you're not allowed to use AES 256. Also countries where the US has export restrictions on AES 256. So you can order products that have the AES 256 removed if you need to use them or send them to countries where you can't use 256. It uses DTLS encryption, which is a similar encryption stack to what's used on the web. With encryption, it's important to use, well, one of the things we wanted to use stuff that was widely used and that had common internet certifications. So if we're dealing with IT departments, we could point to something, and that's why we ended up with DTLS. Now it also supports a pre-shared key. This was something that I ended up having to fight like hell for. There are certain rules in the IT world where in a lot of cases pre-shared keys are considered to be no-nos. However, if you're doing a news feed and you're going from point A to point B and you're, say, a stringer doing the feed, we decided to incorporate a default pre-shared key into the unit. You can also add your own pre-shared key, but the unit does have a default. The reason for that is if you're doing a news feed or any kind of thing, the last thing, let's say a news director ever wants to hear is an excuse for why the feed didn't get on the air. So the only way to ensure that is either A, going in the clear, which can be very problematic and in many cases may lock down the firewalls, or to have a pre-shared key as an option. Many of these, there was a lot of pushback from some of the more security conscious folks on that. So some of these products will actually give you alerts if you go into the default pre-shared key mode. Some have even said they're going to have flashing lights, may even have a beep, and may, if it's integrated with the camera, may even give you something on the heads-up display, alerting you that you are in PSK mode and that you have the risk of a security breach. But having worked in broadcasting, I said you need to make certain that there's a fallback way of getting the feed through. So over objection, the pre-shared key was included. Authentication guarantees that whoever you are connecting to endpoint is who you think they are. It helps prevent you from being like Zoom bombed. Authentication guarantees when you connect to someplace in the internet, it's the place you think it is. Some of the DTLS means that if there's a third party trying to hijack it with the authentication, they would not be able to see your stream, intercept your stream, or feed you alternative content. You don't want something getting on the air that really shouldn't be on the air. RIST uses the same techniques used to guarantee that when you connect to your bank, you are really connected to your bank. Actually, I was going to take that out of this version of the presentation, but I didn't. Sorry. Supports bandwidth optimization with null packet deletion. That typically can save you 5% or more on your internet stream. And when you're dealing with a tight internet feed, you'd rather have that 5% for your video, audio, or ANS data than for overhead packets. And as I mentioned before, it supports high bitrate operations. There is no, within the standard, there is no high-end limit to how high the data rate can be. However, obviously, right now, nobody's making products that support insanely high data rates, but they could if necessary. Here's a list of the various standards and RFCs used in RIST. RIST, as I've sort of said, is like Lego. We really didn't invent anything. We tried to stick with existing standards and RFCs and just sort of put the pieces together to form RIST rather than reinventing any wheels. And so within the main profile, these are the standards and RFCs that are used within the main profile. So you can find products from multiple vendors, encoders built with RIST and support, decoders, gateways, system integrators with RIST experience, and RIST services in the cloud. So, open source RIST. Several folks are making some software right now that can be used and downloaded. So there is RIST that is available as an open source. There's a demonstration of that. And Wireshark has the latest version of Wireshark has some RIST protocols involved for troubleshooting RIST, as well as, and my brain just went blank, the streaming app, VLC. VLC supports RIST main profile. VLC will support RIST, it supports RIST simple profile. And when the next full rev of VLC comes out, it will support RIST main profile, except some of the encryption techniques cannot be used with it because it does not support some of the encryption. But with limitations on the encryption, VLC will support RIST main profile if you use pre-shared key and some of the simple encryption modes when the next full version of VLC comes out. AWS, yes, we have to plug them. AWS supports RIST. They are obviously one of the major supporters. It's also supported by Twitch. So if you are using AWS, you can use RIST right now. It's supported in their data centers. and Twitch is also using it for some of their gaming streaming. So we currently set up a cloud RIST demo. We have these locations that are currently feeding to a server down in Florida. And so we have these providers here who are sending their content currently to a data center. This is all running on blades. There is no hardware. It's all in the cloud and an output stream. Now, if you'll see, oops, hang on, backing up. I see, okay. You'll see there's a URL there. It's also on the link page, and you are free to use that. Now, give me a second here. I'm going to try and call it up. It's going to be a bit jerky because you're watching it via GoToMeeting. Trust me, it's normally not jerky. So give me one moment here. I need to stop sharing in order to change it. Okay, pardon me. I will be back in a moment as soon as I click on the right box. Oops, wrong one. I apologize. I clicked on the wrong one. Sorry, I have too many things open in the background here. Here's the one I wanted. And now if I can share again. Now I know for you guys, you're going to be seeing it as a little bit stop and go, but that's GoToMeeting. So this is a live stream that is coming, as I showed before. It's going down to a data center. It's running strictly on blades in Florida, being RIST decoded, and the multi-viewer and all that, and the RIST re-encode is all happening in the cloud. And like I said, and then the share on the comment window is the link. You're free to click on it and look at it if you want. But like I said, this shows that RIST is fully cloud compliant. Everything you're seeing here, while the senders who are playing back the video, or in most cases, are happening on real hardware, the decode, the multi-viewer, the re-encode, and the output stream is all done in the cloud. Okay, now I got to switch back to my presentation. And back to that, and I'm not sharing. Oh, come on. Sorry, I cannot see the PowerPoint window and anything at the same time. Okay, I'll try it this way. Here. Share. Share. Oops, not yet. Yeah. Do it this way. Share that. And now I can maximize it and go back. Yay, it's back. Yeah, the new version of GoToMeeting, I can't call stuff up when it's open. I'm not quite certain why. Okay. So another interesting thing here is the ability for it to recover. This was an actual test that was done. It was actually done by Cobalt in actually in Orange County, and it shows that we said it typically RIST can support 5% packet loss, but under normal operations for short periods it can support much more. And here's an example here where they found, while actually doing testing, that for short periods of time, the packet loss and the burst loss can be as high as 65% using a standard cable modem. And this was on Comcast in Orange County, California, and RIST was able to deal with it. So the internet can be a very hostile location, and these are typical numbers, especially when you're sending via cable modem, because you have very limited bandwidth on the upstream side, and your neighbors coming off the same node do something, and your bandwidth momentarily gets taken from you, and that's what you have to deal with. I also have to deal with, why is it coming back to me? No. There we go. So RIST use cases. You can use it for straightforward tunneling, either in bidirectional. So sender, once again, through a tunnel, through the internet to a receiver with return data. Bidirectional transport. So if you want, you can send video bidirectionally. I mean, you can use the same, if you're having a RIST encapsulation, you could send return video, like from a TV station back to the person sending it, very much like you do on Skype or anything like that, or Zoom or GoToMeeting. Single to common point through the cloud. So remember, the internet is strictly unicast. It does not support multicast. But using a cloud provider, you could send your signal from your senders or your receivers to a cloud provider and then do multiple point-to-points. So you could effectively do distribution from a cloud provider. And you do not necessarily have to re-encapsulate either. You can take that same stream, pass it through without decoding and recoding, and the cloud provider can maintain the packets that are lost. So if, for example, if you're seeing my arrow here, you send a packet through, in the cloud, you could actually store the data. So let's say you lost a packet going just to this provider, and it says send it again. It doesn't have to go all the way back here. It can just go back to the cloud provider who has the missing packet and can then resend it. So that allows point to multi-point through the cloud with just a single unicast stream from the source. It supports diverse path load sharing. So for example here, let's say you're you're doing a news feed, you're using the Wi-Fi at the local Starbucks, but you've also got LTE. You can mix and merge and use the combinations thereof based upon whatever you have available. It can fully load share. So if you're evenly spreading bits across, it can send redundant bits, do something like a SMPTE 2022-7. So it's flexible as to however you need to use it. Seamless switching, where it switches between one or the other. You can also use it in its bidirectional mode for like a PTZ control that's actually being used right now. There are shows on the air, especially the last couple of weeks, that are currently using RIST technology and RIST to control remote PTZ cameras, currently sitting in people's basements and garages as they do their show. Another thing not in the presentation is that RIST itself is software. And that has come in handy because some of the providers have actually just simply taken a clean PC that was available, loaded RIST software on it, connected up cameras with IP outputs, but that were not internet friendly. So these are cameras with compressed outputs that were designed to use on a managed network where the QoS is obviously much better. But by just simply sending them a software download, they can take that camera, loop it through software on a PC and make it RIST compliant. So therefore, they're able to use existing cameras to send and control them over the internet to get shows back on the air from people's basements and garages. And obviously there is an insane amount of that going on around the world right now. This is something that, hey, there we go. This is something that will be part of phase 3. It's not currently part of RIST phase 2 or main profile. This will be part of what most likely will be called the advanced profile. And that's using a satellite internet hybrid. That was mentioned earlier because of the issue of what's going on with C-band and people having to move to KU and KA. It is possible using some homebrew work to do it now, but there is no standardization on that. In phase 3, which will be out in about a year, there will be. So you will be able to use a satellite and terrestrial hybrid with RIST. That would allow you, if, for example, C-band does go away and you have to move to KU or KA, that would effectively allow you to have what you could market as rain fade free KU and KA. Because if you have an internet connection and your satellite gets corrupted by rain fade, it seamlessly transitions to an internet path. So you take no hits, no glitches, and that may be something that's necessary if C-band proves in the future to not be very usable because of 5G applications. Similar to the last thing that was shown, multicast distribution using LibRIST, which is one of the open source versions of RIST. I sort of explained that in the last similar looking slide, so I'll skip that. And play out from the cloud. Once again, another application of multiple point-to-points, since we can't do point-to-multi-point on the internet. I will point out, though, that RIST does allow you to do multicast once you hit a WAN. So you can do an encapsulated encapsulated multicast within a unicast tunnel. But once you decrypt through RIST and you put it on your local WAN network, like in a broadcast facility, at that point you can go multicast. So there's no need to have multiple copies of the stream going, to have multiple receivers, for example, within a LAN environment. Cloud contribution, quite a bit of that going on right now. Reports to the field, going to receiver sites and other risk compliance software totally in the cloud. And here are some sample deployments. By the way, the final these are real, but I've had to, had to remove most of the names. Avoid that down there, but anyway, these are real, I think, RIST applications that are currently in use from a site to control room monitoring and remote live monitoring services on a managed system. And one reasonably sized station group, which is currently using a RIST, who's currently using RIST and going through a cloud service provider to cross connect and reconnect. Like I said, this is a station group who actually does, I will say they have stations in Georgia, but none in Atlanta. And the May 4th version will contain the actual information. For further reading, here's a list of stuff. The TRO 6-1, the simple profile, is available on the VSF website. -2, the main profile, is available on the website. The link to the VSF activity group page, the RIST forum at http://rist.tv. Once again, they are the marketing entity for RIST, and a performance and measurement study that was done by Cobalt, available at this really, really long URL. And other things. So for past demos, you can Google, you can YouTube search some of these, because we've taken samples of our past demos and left them out on YouTube. And that's what I've got. Any questions?
Craig Kuttner, hello.
Hi, Craig.
Hey, in the output of interops, is
Mhm.
there any kind of gate that is the equivalent of conformance testing that gets you a logo?
At this time, well, you can't say you are RIST without that. Now you can. There is the issue. We're still dealing with the what's the term I'm looking for? The shareware versions of RIST. We're still dealing with some of that type of stuff. So in terms of being actual RIST and not the shareware version of RIST, yeah, you have to have been part of the interop testing in order to claim you're part of RIST. As far as LibRIST goes, no, we haven't sorted that yet.
Thanks.
Okay.
Hi, Rick. John Schilberg here.
Hello.
Question, Net Insight, I recall reading papers, white papers they put out years ago about RIST. Is this the same RIST?
If they use the word RIST, yes, they've been part of the group since the beginning, since 2017. If it's prior to 2017, it would be something different.
Okay.
But
No,
the term RIST,
that would have been about the time.
Yeah. The term RIST was actually a term that was in another paper given in 2017 by Thomas Edwards, then of Fox, now of Disney. Where he used the term RIST, and I liked it, so I stole it with permission. And that's where RIST came from. He used the term reliable internet stream transport, and I thought RIST, that has a nice sound to it, so that's why we used it. So anybody who said anything prior to 17 may have been talking about something else. Since 17, we pretty much have this term.
Hey, Rick.
This was stuff that was associated with Net Insight specifically, and so it was about that time frame. So I think I'm looking at the same stuff.
Yeah, they're a full partner.
Rick, hey, Mike Crowley.
Mike.
Any interop with NDI, Nutec's NDI format, which is kind of they've got a lot of prosumer type devices that interop with.
We have not formally done anything. There has been some playing around, and I'll just phrase it that way. Like I said, RIST is so nothing formal. Technically it could work. The only thing is I don't know if any latency issues could cause problems. But like I said, it's open source. But no, Nutec has not been directly involved with this.
Hello, Rick. This is Bob Castro.
Hi, Bob.
Hi. Is this seen primarily as a broadcast or an origination endeavor, or is there use cases for post-production whereby a client and an editor or a client and a colorist are separated geographically, but the client can see, in addition to the quote program line out, they can also see this like source clips, for example. They don't all have to be rolling, but a producer could say, oh, let me see what's in the upper left or whatever.
Okay, up until 6 weeks ago, we were thinking primarily for contribution, but I know for a fact it's being used for that right now.
Wow.
Like I said, over the last 6 weeks, a whole lot of things have happened quickly.
And I heard you're mentioning that it can take insanely high bandwidth, but as a practical matter, of people who are using it out there, what is the sweet spot for it? Are you talking about like 1080i or 1080 type of pictures, or do they need to be subscaled down into widescreen standard F in order to be zero latency?
If you have an internet pipe that's big enough with a informal QoS that will support it, and you have enough processing power in your RIST encapsulation and de-encapsulation, there is truly no limit. And so it literally, it's a matter of how fast your if you're running it on a blade server where you've got a huge amount of, and you've got a big enough internet pipe. Yeah, I mean, we've done, well, let's put it this way, we've done tests with gig connections of plain old SD uncompressed, because we had a gig connection and it would fit through it. But there is nothing in the standard that limits it. It truly is a matter of how fast your processing power is and how big your internet pipe is.
Sure, and I congratulate you for being that forward-looking. But I guess my question was that from feedback from the field, what are people tending to go for? Are they sacrificing spatial resolution to get good temporal, or is it the other way around?
Well, if you're willing to do compress, I mean, we've done 4K HDR with it in the lab, so that's, it's compressed, not uncompressed. If you're willing to compress, no, people are doing, we've done 4K HDR without any problems there. And your latency, the wild card in all of this is your internet connection, because there is, the internet has no QoS. If your internet connection is good enough, you can scale your latency down to actually you can scale it down to a frame or less, and send however much data you want. But like I said, so that's literally the main thing. The main thing is what is the quality of your internet connection. And internet connections go from extremely high bandwidth of multiple gigs that work great to completely useless garbage and everything in between.
So Rick, of the unnamed people on your slides, what kind of bandwidths and resolutions are they actually using?
Right now, most people are using it for MPEG compressed feeds. At the moment, that's what everybody's really interested in. Some of them are using various formats of HEVC, and I use that slightly generically because some people have things that are almost HEVC with one or two things pulled out to avoid patents. Other folks use full HEVC. So yeah, most folks are using compression, HEVC, but certainly a lot of 1080i, 720p. I'm even aware of some that are doing 1080p 60. It literally depends. With folks looking at a lot of the stuff that's being done right now, and both in the local markets as well as on the networks because of all the stay-at-home issues. Some folks in their home are lucky enough to have AT&T, consumer gig service or FiOS gig or 500 meg, and they can run lots of stuff at high data rates. Some other folks, unfortunately, are stuck with Comcast cable modem with a unreliable, 8 to 9 megabits very reliable, 12 megabits less than completely reliable, and have to deal with that short-term 65% packet loss that I showed you on the previous slide. So it literally all comes down to what internet connections are available for the first mile and the last mile. And it's all over the place out there, and that's for hardwired. Obviously, 4G is even, I shouldn't say that. 4G in many cases can be better on the upstream than a cable modem, but it all depends on your internet connectivity. So some folks are running high data rate, some folks are forced to run lower data rate.
All right, well, Rick, thank you very much.